Hello, and a warm welcome to the Al-Attiyah Foundation podcast. My name is Stephen Cole. Today, I am delighted to be joined by Yasser Al-Jaidah, who is the CEO of Qatar Cool, the leading district cooling company in Qatar. Mr. Al-Jaidah has over a decade of vast experience in the energy industry and is also an expert in the fields of maintenance, operation engineering, project management, and marketing. Before joining Qatar Cool, Yasser was the general manager and director of South Hook LNG in the UK. So, Mr. Al-Jaidah, welcome to the Al-Attiyah Foundation podcast.
Well, thank you for the warm welcome, Stephen. I'm delighted to be here, to have a chance to discuss the transformative role of district cooling in Qatar and beyond. As the CEO of Qatar Cool, I'm passionate about the advancing sustainable, efficient cooling solutions that meet the needs of our communities and the environment. I look forward to diving into the details of district cooling and how it works, its benefits, and how we're becoming an essential part of the urban life here in Qatar. And I'd like to before we start, a big thanks to Al-Attiyah Foundation for this great opportunity.
That's a wonderful introduction, Yasser. Thank you. So let's get into the detail. And can you tell us more about the core function of Qatar Cool?
Well, at Qatar Cool, we really are changing the game for cooling in commercial, residential, and mixed-use spaces. Instead of everyone relying on separate systems, we provide a centralized solution that makes everything more efficient and easier to manage. Our systems are built with advanced energy-saving technologies, so they use less energy than the traditional air conditioning. It's not just about cooling, it's about doing it smarter, more sustainable way. By working on a large scale, we're able to keep costs down, reduce maintenance for our clients so they get more affordable, hassle-free cooling that really works for them. Sustainability is a big focus for us. Our practices are designed to lower greenhouse gases because we believe cooling shouldn't harm the environment. And we're committed to customer service, from support to maintenance to monitoring and billing. We're there to make sure clients are getting the best experience possible.
Well, I can second that. As a former customer of Qatar Cool in Doha,
that's great.
Customer experience was extremely good. But how does district cooling technology work, and what are its key components?
Well, district cooling might sound complex, but it's really about making cooling more efficient by centralizing the process. So how it works, try to simplify this. It all starts with a centralized cooling plant. This is where we produce the chilled water, the backbone of the entire system. From there, we have an insulated pipeline network. Imagine a grid of underground pipes that carry this chilled water to different buildings and facilities throughout the urban landscape. Once the chilled water reaches a building, it flows through a heat exchanger, or what we call an ETF, energy transfer station. This device transfers the cooling energy from our water to the building's own water, which is what actually cools the air inside. After the water has been absorbed or absorbs the heat from the building, it returns this water back to the central part to be recooled and reused in a continuous cycle. So this system relies on key components. The key component being the chiller, which is basically the machine that removes the heat from the water. Then the cooling tower, which releases excess heat into the atmosphere. And this is where we get most of the complaints, unfortunately, because they see some vape coming out of buildings thinking that it's a fire. In real essence, that's basically the release of the heat in the atmosphere. It's what's actually causing these. And then there's the pipes and insulated pipes that keep the chilled water cooled as it moves throughout the network. And then there's the pumps and the control systems that monitor and manage everything to keep it running efficiently.
Now, district cooling obviously requires an energy input. What are the primary energy sources for the district cooling systems?
Well, district cooling does need an energy source to run, definitely, and there are different options, each with its own advantage. Of course, here in Qatar, we use electricity, so electricity is the most common go-to, especially when it comes to energy sources that are limited. It's reliable and widely available. Uh, I basically have seen natural gas as another option, especially in systems that use combined heat and power or absorption chillers. We're also seeing a huge shift towards renewable energy like solar or wind to power cooling plants and to make the whole system end-to-end sustainable. So district cooling has a flexible energy profile, which means we can adopt it to different needs and even make it more sustainable.
So district cooling is a competitor to standard air conditioning that most people know well. But what are the key differences between the energy efficiency of district cooling and the more traditional air conditioning systems?
Yeah, I mean, district cooling is centralized, efficient cooling solution that basically services multiple buildings within large-scale chillers. Unlike the traditional air conditioning, which relies on individual units for each space, district cooling consumes 60% less energy due to its economic of scale and advanced technology, while also optimizing the heat rejection, which is centralized in cooling towers. This setup allows for lower maintenance needs, reduced downtime, and smaller carbon footprint. Additionally, district cooling is cost efficient, leveraging shared infrastructure and scale efficiencies, where traditional air conditioner incurs higher cost and it's less environmentally friendly due to its decentralized, less efficient units.
What role then does thermal energy storage play in district cooling systems? Is chilled water stored in Qatar Cool systems, for example?
Absolutely. Qatar Cool uses chilled water storage to boost system efficiencies and reliability. This basically storage helps match cooling supply to demand, especially during peak times, reducing the need for continuous chilling operation. It also provides operation flexibility by allowing us to produce chilled water during off-peak hours, which cut energy costs and lessens the strain on the grid. It actually is very, very essential to have when you have a dual tariff system and within the kind of utility network. But for us, we do it predominantly ensuring that we're a lot more cost effective and a lot more energy efficient in how we use our energy.
Okay, well, apart from increased energy efficiency, what are the other environmental benefits of district cooling systems compared to individual cooling units? You mentioned the magic word sustainable. Is it genuinely more sustainable?
Absolutely. I mean, district cooling brings major environment benefits. I mean, in Qatar Cool alone, we've cut over about 150 million kilograms of CO2 emissions annually, while also lowering the urban heat island effect by reducing individual outdoor units. Our robust system also minimizes refrigerant leaks and saves over about 270 million kilowatt hours annually through energy recovery. Centralized cooling reduces noise pollution in urban areas and conserves resources by optimizing water use. I mean, for us here, we use treated sewer effluent in our plants, easing the demand on potable water. So it's absolutely sustainable as a whole.
You hit on a subject that's obviously very important about use of water, and sewage effluent is a great example of recycling, isn't it? And
Definitely.
that could work in more Arab countries, with more arid countries with less access to water.
Uh, I mean, well, less to water, definitely. I mean, we've got places where you could use district cooling, especially and the application of using air cooled chillers instead of water cooled chillers. So definitely.
Okay. How reliable then are the district cooling systems in terms of service continuity and obviously resilience to disruptions?
I mean, our district cooling systems are designed with reliability and reliance in mind. So it's very initial phases. We've basically strategically planned our infrastructure, placing the right number of cooling plants exactly where they are needed based on the projected demand. They're all connected by a centralized piping network. So we have ample capacity to keep things running smoothly, even as new developments come online. Plus, with the dual power supplies, we're prepared to handle any kind of power outages without disturbing the service. We've got obviously routine maintenance is another key aspect of what we do. We're continuously inspecting, fine-tuning our equipment, which means we can address potential issues early on and avoid unexpected interruptions. I mean, we're built to scale. We can increase or decrease cooling capacity based on the demand, which helps prevent overloading. And with a thermal storage, we can handle peak demand at times without missing a beat.
Well, that was what I was about to ask, actually, yes, about how scalable are the cooling systems for expanding urban areas and new developments?
Well, very, very important because obviously when we do initiate a plant, it's never at the end of an urban design. So our district cooling system are designed to grow with the city. We use modular components, so we increase. So as the demand increases, we can easily add chillers or extend our pipeline network to new buildings. Our thermal storage is also scales up to handle the peak loads. Adding new cooling plants or expanding the existing ones is straightforward, allowing us basically to meet the urban growth efficiency. We integrate new technologies without overhauls, making upgrade cost effective, and our advanced forecasting tools helps us plan for the future. So as we expand, economic scales keep costs down and improve efficiency.
Can you tell us more about the cost benefits of district cooling for consumers in the long term?
In the long term, I mean, district cooling offers consumers significant cost benefits. Lower energy costs come from economic scale and efficient operations at our centralized plants, which use far less energy than individual units. Maintenance are also reduced as fewer components means less upkeep compared to the additional setup. I mean, district cooling also offers stable, predictable pricing with two main fixed fees. There's the fixed capacity fees and the variable fee, making it easier to budget for cooling. I mean, reliability is another major advantage with built-in backup systems, quick response team. District cooling minimizes downtime and unexpected repair costs. So finally, consumers can benefit from reduced regulatory compliance costs as we handle basically all environment standards centrally.
And how does the initial investment in district cooling infrastructure compare to traditional cooling systems, say, for example, in large apartment or office blocks?
I mean, this is where district cooling does require a high upfront investment compared to traditional systems due to the cost of the centralized plant and distribution network. So that's a huge capital cost that needs to be incurred. However, because these costs are shared across multiple buildings, the per cost decreases as the system scales up. While integration with the existing or new system can add some cost, district cooling proves basically to be a solid long-term investment. Its energy efficiency and lower operational expenses lead to significant saving over time.
Can district cooling systems be adapted for use in different climates and regions?
Yes, district cooling can definitely be implemented in existing urban areas, but it comes with some key challenges. Integrating the new infrastructure with existing utilities is complex, especially with limited space for pipelines and cooling plants in dense areas. Retrofit costs and the high initial investments are also significant, along with the potential disruption to the daily life, like construction impacts and temporary cooling interruptions. I mean, there's also the aspects associated with public acceptance is absolutely essential. So we need to make sure clear communication about the benefits and cost and potential disruption that helps build support. Finally, we need a kind of robust plan that fits with the urban maintenance practice to ensure that the systems run effectively on the long run. This is something that Qatar is also thinking of actually implementing in specific areas that are what they consider or classify as district cooling friendly. And it's an initiative that we potentially see ourselves being the poster boys within applying this technology as we proceed forward.
How does district cooling integrate with smart city initiatives and sustainable urban planning?
Well, district cooling fits well into smart city and sustainable urban planning initiatives. Through the real-time monitoring, predictive analytics, we optimize system performance and energy use while integrating seamlessly with the smart grid to manage basically demand and reduce the strain on the grid itself. Our systems also use automation. We've been using artificial intelligence as actually before really artificial intelligence really caught on through kind of remote access to ensure that we are efficient and we are responsive in our operation. By also centralizing our cooling facilities, we cut down on energy consumption, we reduce emissions, we help mitigate urban heat, which also supports the green spaces and sustainable urban layout. We're future-proofed too. Our scalable, adaptable infrastructure goes with the urban development, and we incorporate renewable energy where we see fit.
It's very sophisticated, yes, especially being so far ahead of the curve using AI. Is that going to play a more of a role, do you think, AI?
I mean, in our facilities, definitely. It's either you change and adapt to new technologies, or you find yourself as being changed. So,
and always playing catch up.
Yes, and so what we felt and it was necessary to do is be at the forefront, and so we've applied AI in all facets and within our facilities. But we take really pride in what we have recently done. We've actually established a couple of IPs in AI as in within our industry. We are actually the third, if not fourth, largest district cooling company in the world. And being this large, we really don't have a comparison or a benchmark that we potentially benchmark ourselves. So it's very important that we are actually at the forefront and spearheading all effort and being the pace setter in our application of or in adapting new technologies.
Just one last question. Yes. So what are the maintenance requirements for district cooling systems, and how do they compare to the more traditional systems?
I mean, district cooling system, has a rigorous maintenance program. We have a rigorous maintenance program. Obviously, we have to have specialized teams to keep the operations running smoothly. We follow very strict regular inspections and preventive maintenance checks on key components like the heat exchanger, valves, piping, everything in between. We have real-time monitoring and predictive maintenance. This is where we actually have applied artificial intelligence to allow us to detect potential issues before they disrupt the service and to ensure that we minimize, if not eliminate, downtime. We also maintain our extensive pipeline network and our cooling towers routinely to ensure top performance. Compared to the traditional system, district cooling benefits from centralized, professionally managed maintenance, advanced monitoring, which leads to fewer breakdowns and more reliable and consistent service.
Well, Yasser Al-Jaidah, that answer concludes our interview. Thank you for providing your great expertise on how district cooling works, its environmental benefits, sustainability, of course, and how it's integrated using AI into our daily lives. It's fascinating to learn more about this subject, and thank you to the listeners for tuning in. A new Al-Attiyah Foundation podcast will be released in the coming weeks, but for the moment, from me and from Yasser Al-Jaidah, it's good.
Well, if I could say thank you to also for having me. It was a pleasure to share insights on the district cooling and discuss how it actually is shaping sustainable urban living. I hope this conversation helps more people understand the value of efficient cooling and the positive impact it has on our environment and communities. And to all the listeners, thank you obviously for joining us. And I look for more discussions like this in the future.
Excellent. Superb. Thank you so much, Yasser. From me,
Thank you.
Stephen Cole, it's goodbye.